This is 5.2, which goes into the graphs of reciprocal trig functions. So we're talking about the cosecant, the secant, and the cotangent graphs. Now let's start off with the warm-up. Number 1, determine the value of sine theta in exact form, given that you have the reciprocal, which is cosecant theta, and that equals to root 7 over 5. So if I know that this is the reciprocal of sine theta, that means that the reciprocal of this fraction must be sine theta. Okay, so sine is equal to 5 over root 7. That could be my final answer, except I don't like roots on the bottom. You want to make sure anytime you have roots on the bottom, you rationalize the denominator by multiplying root 7 over root 7. That's going to give you the whole number 7 on the bottom, and then we're much happier. Okay, so number 2, let's take a look at the cosecant, secant, and cotangent graphs a little bit more in detail. And maybe if we could figure out some features of the graph, like the x-intercepts or the vertical asymptotes, then we'll kind of have a picture of what they start to look like on paper. All right, so the x-intercepts can be solved by making this equal to 0. Well, if it equals to 0 and I cross multiply to start solving for my theta, theta is going to disappear. That means that I have no zeros. So the cosecant graph has no x-intercepts. Well, it does have vertical asymptotes though. Remember, a vertical asymptote happens when the denominator equals to 0. Sine theta is equal to 0. Let me see what the graph looks like. Well, it looks like it equals to 0 at 0, pi, and 2 pi within this span of domain. Okay, so in other words, I'm thinking like every pi, and how exactly do we write that? So the vertical asymptotes happen at n pi, where n is any integer. Now let's take a look at the middle. So we're talking about the secant graph now. The same thing happens, no zeros, because when you make it equal to 0, your theta is going to disappear. And then the vertical asymptotes happen whenever cos theta is equal to 0. So let's check out that graph for a second. Cos theta, that's what cos looks like, and it looks like it's equals to 0 at pi over 2 and 3 pi over 2. In other words, anytime you have an odd number in front of the pi and then divided by 2. Okay, so that could be written like this, where you have no zeros and your vertical asymptotes for the secant graph are n pi over 2. N's going to belong to any odd integer. Now the cotangent graph, well, it's going to equal to 0 anytime your numerator is 0, because 0 divided by a number is 0. It's going to have a vertical asymptote whenever the bottom is equal to 0, because, well, when your denominator is equal to 0, it's undefined. Now we already solved for those. Cos theta is equal to 0 at this purple part, and then sine theta is equal to 0 at this blue part. Okay, so in other words, these are your answers. Again, those give us a glimpse as to what the graphs actually look like. But you know what? I'll fast forward a little bit. I'm going to graph them all for you using any of the special angles, such as pi over 4, pi over 6, pi over 3. Any of those special numbers, I'm actually just going to sub them into theta and start graphing. So here is a lot of information. I know it's kind of small, but you're just going to have to squint. We have the 3 reciprocal graphs on the bottom. Okay, so in dotted lines, you have sine, cos, and then you have tan. Okay, and then in the red, the blue, and the purple, you have your 3 reciprocal graphs, which are your cosecant, your secant, and your cotangent. Now above, we have all of the analysis, which is on sine, its reciprocal, cos, its reciprocal, and then tan and its reciprocal. And we analyzed using this following features. So we talked about the period, the vertical asymptotes, and the x-intercepts, or the zeros. Now when they say positive intervals and negative intervals, they're talking about when is a graph above the x-axis, in other words, has positive y values, and when is it below the x-axis or has negative y values. Okay, intervals of increase and decrease is talking about positive slope and negative slope. Then the max and the min are, well, you know what maxes or mins are. Okay, so some major features. Your cosecant and your secant graphs both have 2 pi as the cycle. So for instance, if I'm just looking at secant, this branch right here is repeated right here. So anything like this part, and that u is going to be repeated here, here, and here. In other words, within a 2 pi domain. Okay, now cotangent and tan are different. These guys have half of that span as their cycle. Okay, now we already talked about vertical asymptotes. I do want you to notice something. When you have the sine graph, you have no vertical asymptotes, but that kind of crosses over where your reciprocal has no zeros. The zeros of your sine graph are going to be your vertical asymptotes of the reciprocal. Because again, if sine is equal to 0, you're going to get an undefined answer. Okay, now let's just talk about, say, the positive and negative intervals again. In terms of the cosecant graph, it is above the x-axis right here from 0 to pi, and then, well, that's it, within a 2 pi domain. It's going to be negative from pi to 2 pi in terms of just a 2 pi domain. So that's what's written right here. And again, you can take a look at the other two graphs. I don't have time to go over all of them, but you can always freeze frame this slide. Okay, now in terms of the intervals of increase and decrease. Well, we talked about this one, we talked about this one. Let's talk about the cotangent. Tan, the dotted lines, are always increasing. Always. They always have a positive slope. But the cotangent never has a positive slope. That's why it says none. It does always have a negative slope, so it's always pointing downwards. All right, so these are the intervals where it's going to be negative within a 2 pi domain. In terms of maxes and mins, none of these guys have maxes or mins, because if you take a look at all of the end behaviors, they're always going up forever or down forever. Okay, it's just something that they all have in common. So this is our last example. What is the difference between the graphs of f at x, well, f at theta, and g at theta? If you look carefully, you'll notice that these two fractions are both equal to cotangent theta. So which is a better model for the graph of cotangent? Let's look at both of them separately. Okay, so the first one is going to have vertical asymptotes when sine theta is equal to 0. And we've already determined that that's at n pi. So any integer before a pi. Okay, now the other one, this one, you know what, I'm just going to rewrite it first. 1 over tan theta is equal to 1 over sine over cos. All right, and now I'm going to analyze the restrictions. So first of all, the restrictions on this entire thing. Now, if I have 1 over a 0, that's going to be a problem. But when does this small fraction equal to 0? Well, this one equals to 0 when sine theta is equal to 0. So when sine theta is equal to 0, this entire fraction doesn't work. And we've already determined before that that's at n pi. Now, this one has an additional restriction. In just this little fraction, we're not even talking about like the entire fraction, we're just talking about the tan theta. Tan theta won't work if the cos theta is equal to 0. So that is at n pi over 2. This guy has a double restriction, and you know what, that's a lot to deal with. So I'm thinking, you know what, the very first one, the green one, why don't we deal with that, because it just has restrictions on sine theta, whereas g at x has restrictions on both the sine and the cos. That is a lot of restrictions, and it's a little bit too much. So the better model is just going to be that original cos theta over sine theta for the cotangent final graph. Okay, now this tutorial hopefully is a little bit more enlightening for you on the 3 reciprocal trig ratios.